Hey guys, welcome back. Now let's get started with our day 6 walkthrough. So here the learning objectives are: understand how specific languages may not handle memory safely, understand how variables might overflow into adjacent memory and corrupt it, exploit a symbol buffer overflow to directly change memory you're not supposed to access. Memory corruption. Remember that whenever we execute a program, all data will be processed somehow through the computer's RAM. In this video game, your coin count, inventory, position, movement speed, and direction are all stored somewhere in the memory and updated as needed as the game goes on. Usually, each variable stored in memory can only be manipulated in specific ways as the developers intended. For example, you should only be able to modify your coins by working on the PC or by spending money either in the store or by changing your name. But what happens if we can directly change the contents of the memory space that holds this coin count? What if the game had a flow that allows you to override the pieces of memory you're not supposed to? Memory corruption vulnerabilities will allow you to do that and much more. In the game, we can use the tab key to see the debug panel. So as we can see here, the player name has 12 bytes allocated to it. Then comes the coins. So the 13th byte has overflowed into the coin section. So here you can see 78, which is the hexadecimal value of X. Whereas the ASCII value is 120, so you'll receive 120 coins when this change happens. So initially the player name is set to cat or mouse. But if we change the player name to elf here, the bytes will be overwritten here, as you can see here. So when the game displays the player name, it is supposed to display elf or mouse. But this is not the case. This is because there is a null character over here. So once the null character comes in, it terminates and it only prints elf. Now let's go ahead and start our machine. Now let's go to our machine. Let's hit tab. So this is the ASCII version, and if you hit tab again, you can see the hexadecimal values. To finish the game, all you need to do is to get a star to put on a Christmas tree. Now let's go to the computer and collect our coins. You can either click on spacebar each time or you can just keep holding it. So now let's check out if this overflow works. So let's take 13 to 14 coins. Now let's go here. So now let's give a name with 14 characters to check if this overflows into the coins. So as you can see here, the last two characters of our name has overflowed into the coin section. Now let's go to the inventory. So here we want to buy star. Here the ID is D, so type in D. But if you notice in the inventory here, we haven't received the star, we have got some other item. Let's try this again. So as you can see here, it's not working. Since we know the ID of the star, so if we are able to change this inventory byte to D, then we should get a star in our inventory. So we can try this by manipulating our name. So it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 into 4 is 44. So 45th character should become a D. Now let's hit on enter. So as you can see here, by changing the name, we have been able to overflow and change the value of the inventory. And now we have got the star. Now let's go to the Christmas tree. So now we have captured the flag. Let's go back and answer the questions. Now let's click on submit. Coming to the next question, if the coins variable had the in-memory value in the image below, how many coins would you have in the game? So there's the hexadecimal value here, so we'll have to revert it and convert it. Now hit on convert. Now let's copy this value and paste it here. So we have successfully completed our day 6 walkthrough. Thank you for watching my video and stay tuned for more.